Hello everyone, today is either Thursday or Friday, the 24th or the 25th, I think. Nope, the 23rd or the 24th. And I'm gone on a Unified Studies field trip, so here's what you're doing today. I just want to review our Learning Target 1 really quick. So what you're going to do today is the worksheet for Learning Target 1, and you're going to turn that in at the end of the day. So our Learning Target 1 is all about reaction rate and collision theory. Here's what we needed to know on that. The first thing we need to know for this is reaction requirements, or what's required for a reaction to happen. Okay, now in order for two different molecules, particles, atoms to react, these three things need to happen. Those particles need to first collide. They need to hit each other like my Freaky Friday story. Second thing they need to do is they need to not only collide, but they need to collide in the right orientation. They need to be in exactly the right setup for that collision to work. So if A wants to react with B, it needs to be facing that way. A cannot be running into C if it wants to react with B. That's not going to work. And third and last, it has to have enough energy to send it over the activation energy. So let's review activation energy real quick. Activation energy is the energy required for a reaction to happen. It's this little bit right here to get that reaction started. Okay, remember this little bit at the top of the graph as well has a special name. It's the activated complex. And this is the point where our reactants and our products have collided. And that exact moment they're colliding, that's the activated complex. Sorry, it's kind of squishy in there. We also need to review the different types of reaction you can get, the different enthalpies, the endothermic and the exothermic. And endothermic, our energy is being absorbed. So energy is going in. So if this is a reaction, endothermic energy is going to go in. That graph, because we're absorbing energy, is going to end higher than it begins because we're absorbing this amount of energy. That delta H is going to be positive because you are absorbing that energy. Exothermic energy is released. Endo enter, exo exit. It's going to heat up because that energy is going to come out. So when you feel it, it's going to feel hot. Our graph is going to end lower than it starts. And because of that, our delta H, or change in that enthalpy, is going to be negative. Okay, that's the first little bit. If you have questions or don't remember stuff, look at your notes on pages 5 and 6. That's what I basically reviewed here in a nutshell. I do encourage you to take a look at your graph on 6 in very, very close detail before you start doing your assignment. Or while you're doing your assignment, look back on that because that graph is going to show up a lot. Okay, now I'm going to review page 12. So the next thing we needed to know with this learning target is the 5 factors that affect reaction rate and be able to look at and interpret graphs based on that. So there are 5 things that affect reaction rate. We kind of talked about 6 in class, but these are the 5 that are going to show up more. We talked about nature of reactants. If the element is more reactive, then that reaction is going to typically go faster. That's not one of the 5 that's going to show up on your assignment today, though. The first that is stirring. So I want you to think back to when we talked about why these make it more reactive. You do have notes on that, and you are all smart enough to figure that out with these 3 things. So what does stirring do that helps the reaction happen faster? After stirring, we have temperature, and that is a temperature increase that's going to make it go faster. Decrease, make it go slower. And again, with stirring, I want you to think with these 3 things why it makes it go faster. After temperature, we have particle size or surface area. The bigger the particle size, smaller the particle size, the bigger the surface area, the faster the reaction. So when you break it up, it's going to react faster. Next is concentration. The more concentrated it is, the faster it will be. And last but not least is the presence of a catalyst. So again, what we really want to emphasize here is the why. And we all went over in class in a lot of detail why these things speed up a rate of reaction. So if you need a reminder, look in your notes. But if you didn't write them down, you are all smart enough to think, okay, thinking of these 3 things, the collision, orientation, and energy, why do these 5 things make a reaction go faster? Okay, I want to keep this short so you have time, but remember we did many models of proficiency on pages 13 and 14 that are going to help you a lot today with your assignment. Your notes on 12 and I think 5 and 6 are also going to help you a lot, so look at those pages for a reference. You are going to be doing today pages 15 through 20. Now 20, it's only the very first question at the top of 20. It looks like a lot, but it really is not it. You should all be easily able to finish in class if you are working and you are working consistently with each other. If you have questions, email me. I will get back to you as soon as I can, but I am in the middle of nowhere, so I do not know how my service will be, but I will try my best to help you. This will act as a test score, so make sure you finish it and turn it into the box when you are done. Do not turn your whole packet in. Just tear out page 15 through 20, staple it together, and turn it into the box, and I will grade it when I get back. The key will also be with the sub. As soon as you are done with the entirety of the packet, you can come up and take a look at that. On page 16, for questions 4, 5, 6, and 7, try to write in full sentences. Otherwise, the rest should be straightforward. Have a great day, guys. And I will see you on Tuesday. Monday or Tuesday for you guys. Have a great weekend.